Florian Graichen, welcome to the podcast.
Thanks for having me, Peter.
So you know a lot about forestry.
Yes, so forestry is a big part of what we're doing here at Scion. So Scion, most people probably haven't heard about us. We are one of 7 New Zealand Crown research agencies. So these are government-funded companies targeted with research, innovation, technology development for the benefit of New Zealand in social, economic, and environmental areas. And Scion historically comes out of the forestry part of the economy. And as you can imagine, over the last years, decade, we have broadened that. So we're looking at forestry as a critical part of what we do, but there's also other biomaterials, other biomass, and much more also now the emerging bioeconomies, advanced bioeconomies, circular bioeconomies.
It's a huge area. So you'll have to set me straight. Here in the States, when we think about a lot of this bioeconomy, it's become RNG or renewable natural gas. That's become very big here in the United States, taking some kind of waste feedstock. A lot of times it's from a landfill or some other type of method like that. But then also they're looking at lignocellulosic biomass, which I think of as a biomass type of a product, and now converting that into some form of renewable natural gas to replace the existing RNG. Is that one of the things you're looking at? I'm sure it's broader than that, but tell us about overall what you're looking at in some of the end use products and markets.
So if I take Scion, and you're right, so our look or our definition or the way we look at circular bioeconomy and bioeconomy is wider. It's a different view of the economy where we put society and environment and people at the center. You've got your planetary boundaries that we at the moment are brilliant at infringing. And then you have different types of industrial or biological circles in there where you do, processes as you've described. So within that, Scion is looking at 3 distinct big areas. So one is forests to landscape. So this is where we're looking at forests for truly the benefit or the standing benefit of the forest. So if you can imagine, you spoke about the use of industrial products, but forests is so much more. If you think about recreational value, forests in the city, the benefits that trees bring there, mountain biking, soil erosion, water quality, air quality. So there's a whole area dedicated to that. And this is largely focused on native trees. Then we have one area that focuses on the material wood. And wood is an amazing material. So if you think about construction, we are building with steel and concrete. Concrete is one of the most polluting or environmentally impacted materials. You could build with wood and store carbon that way. You can make amazing materials, products out of wood. So that's an area. And the area that I'm looking after is the area that deals with bioenergy. So we are looking here in New Zealand as bioenergy is complementary to all the other sustainable energy resources. You've got solar, wind, hydro, and for us, it's important. It's not one against the other. There are applications for each of them that are really important. And we believe bioenergy has a specific role to play in the area of sustainable aviation fuel, in the area of marine fuel, and in the area of industrial heat. And then that is complemented through others. And the other parts I'm looking at is turning this using biomass or waste just for commodities. So we are looking at a whole pyramid starting from the highest value. You can think of cosmetics from biomaterials or pharmaceuticals, nutraceuticals, and then working the way towards plastics, advanced materials. The plastics we have today is because we learned how to process crude oil. Now we've got different materials, so our plastics could look different. And then we have one area that is very specific to the nature of biomass and the fact that biomass is distributed. Biomass is not like crude oil where I can drill into the ground and have these big reservoirs. Now I have seasonal, regional, scattered materials. So I also have to rethink how I process. And this is where our approach of distributed manufacturing comes in. We're thinking more of bringing factories to the feedstock and not like we've done in the past, feedstock to factories.
That's a really interesting topic to unpack. So distributed manufacturing and some of the materials like plastic. I think if we could make a bio-based plastic, there was an article recently in the Wall Street Journal talking about huge demand from large companies that have made GHG commitments, and bioplastic can be a very convenient and effective way for them to meet those commitments. So the demand we're seeing for bioplastics going up significantly. Maybe unpack those two topics. First, distributed manufacturing, and then maybe a little of a dive into bioplastic and what you're seeing there.
Yeah, I'm happy to do that. So distributed manufacturing, that's an area we really kicked off probably 2 or 3 years ago. You can see it now emerging in other countries as well, in Europe, in North America, Canada. And as I said, the critical part there is that bioeconomy, circular economy has huge benefits for regional areas, rural areas. So it's a massive opportunity to revitalize areas that might have lost industrial or high value type processes and production. And this is, we believe that you need to bring these factories or these processes close to the material. And then you also have the opportunity to make it a rural or regional specific product, because there is knowledge, there is something specific around the biomass from that region. The other advantage is we are talking about smaller factories, and they could be mobile, don't have to be mobile. But what that allows is to kickstart and drive new industrial clusters or industrial symbiosis much quicker. What that also helps is you always have the challenge of transporting biomass, because biomass is packed with water. So it's very hard to transport that over long distances. So you might have 100 kilometers, 80 kilometers that you can transport biomass. Then it becomes uneconomical. So the opportunity is there to have smaller of these distributed modules, condense, densify, make products in their own right, or allow them for bigger hub and spoke models to function in biorefineries. We've done now this with several partners in New Zealand, and it's really fascinating to see how rural communities or communities come together and start embracing that. And suddenly I get jobs, engineering jobs, biotech jobs, material jobs, really well-paying jobs into parts of the country that you wouldn't have had that before. I
That's
think that,
incredible. Before you go into the bioplastic, I
yeah,
want to dig into this one a little more. It's in my mind, we had this industrialization where
yep,
everything became very commoditized and the knowledge got really centralized.
yep.
And you have these centralized production models, then
Mhm,
vast transportation networks that don't
mhm,
really require too much specialized knowledge. But when you get into this smaller manufacturing, as you say, there may be differences regionally in the different kinds of biomaterials that are there. So the local community has to actually know something specific to that region. And then so you come to kind of, I almost think of it like almost artisan manufacturing. It's not as artisan as making each pair of shoes, let's say individually,
mhm.
but it has more specialized knowledge than some of the call it mass produced industrialized
Mm.
factories. Is that a fair way of thinking about it?
Yep. So when we introduced this concept to our board, obviously people haven't heard about it before, and people come from the perspective of um, productivity by scale, and everything has to be done by scale. So we used the concept of microbreweries, that imagine how they emerged and popped up and how they revolutionized the beer industry or the industry, and
You're
how
speaking my language there.
yes, yes, it's one of the easiest way where people always get distributed manufacturing when you say you picture a microbrewery and not a mass production type brewery. There is space for both, but there are advantages and have both have advantages and challenges. But if you go even a little bit further into the future, so the reason why we've set up the supply and production chains are because our industry is built on crude oil. And now going forward, if you look at the climate change challenges and the planetary boundaries challenges, we need to leave more crude oil in the ground. At the same time, we've got a growing population. We don't want to go backwards. We still need our clothes, our, the items of daily living. So that needs to come from somewhere else. And this is now the opportunity to rethink that, where biomass has a role to play. It won't solve everything. We won't be able to keep our current way of living very wasteful, make, take, waste, throw away. We have to rethink that as well. But we need that source of carbon out of biomass, complementing that with recycled material, complemented that with reusable materials to keep going. And I think that's where it's probably a good segue into the part of bioplastics. And similar there, bioplastics alone is not the answer to all the challenges. So there's always, you hear plastics is a very polarizing topic. So some people have that when they think of plastics, they think of plastic waste, they think of plastic at the beach, they think of these little pesky fruit stickers on your apples and on your pears. They think of, all the things you throw away and that don't really add much value or is perceived. But what they don't see is plastics. If you take the next generation of airplanes, so they are based on high-performing materials, plastic-based materials, composite materials. You think of a hospital. If you would go to a hospital without and eliminate plastics from a hospital, that wouldn't work. You think of printable solar cells backed on plastic. So plastics are things, not just what people think is an issue. So what the better conversation is probably around plastic waste or plastic pollution. It's not about getting rid of plastics. And within that, again, coming back to the current state of how we make plastics is large volumes today are made from petrochemical or petroleum. And if you look at the predictions of various institutes, you go to 2050 or 2060, then we will stop making plastics from crude oil. So the question is, where do the plastics come from? At the same time, the amount of plastics will grow. And the predictions are there. You've got pretty much three sources for your materials. So one is recycled materials. So we've made billions and billions of tons of plastics already. How do we keep that in the loop of remaking, reusing? Then there is the emerging technologies around direct conversion of CO2. So CO2 from the atmosphere into materials. And the other part is using biomass. This is where bioplastics come in. And the thinking is there that it doesn't matter how good your recycling systems or your reuse systems are, you will always lose some of it because of something gets broken or it leaves the cycle. And so this is where CO2 and biomaterials come in, that we will replace these smaller percentages, still huge amounts, but these smaller percentages in a bigger cycle. And so when you spoke about that Wall Street article, and we can see that as well with companies, that now there is that appetite to design plastics better, to design products better, to think from the end of life backwards. In the past, it was just how good does this product function? Now, when we speak with engineers, the first thing is, what materials do I use? In what recycling or in what loop do they feed in? Is it multi-materials? Is it single materials? Where do I get them? Are they, sustainably sourced? What's the supply chain? So it's much more complex than that. And that's where bioplastics, definitely has a role to play.
I think that's very insightful. And a key point you make is when you're talking to the engineers, asking them to be thoughtful about these things, because our engineers are so brilliant. Just it's a matter of directing what matters and letting people think deeply on some of these topics. I know you recently were speaking to some engineering students, and I'd love to hear more about what you shared with them.
Yeah, so we had two events there that happened recently. So it's quite interesting stories, actually. So one was around what in New Zealand is called National Research Science Challenges or National Science Challenges. And this is working across different institutes, targeting, big, really, really aspirational goals. And in that context, what we did, we brought design students in the context of product design students and engineer and scientists, material scientists together. And we talked about, design these new products from a sustainability lens. And the interesting thing was all the engineers always ask at the start, what are the products or what are the materials you have? And we wanted to turn it around. No, you design the product to the best sustainability specifications as possible. You set the material challenge and we respond. It's flipping it around. And that was interesting. That took a while but these materials don't exist. Doesn't matter. You describe them. And so suddenly we saw also with the academics we worked with that they acknowledged, look, we have actually changed how engineers now design products, that they will not just go to their companies anymore and design it as they've always done. They will start thinking differently and ask for different types of products. So that is actually really exciting. And the second part was I had the opportunity to speak to chemistry, science, and engineering graduates at a graduation ceremony. And as you can imagine, when you do that for the first time, you go to the internet and you Google great graduation speeches and you look at them and you get absolutely paranoid and, oh my God, they were so amazing. So I thought, what could I share with them? And there were two things. I thought, well, I'm a chemist myself, I'm a scientist, and I'm a dad to two kids. So the things you get really good at as a dad is answering questions with why. And so I thought I'll answer 3 why questions related to science and the future sustainability for them. And what I answered was around, why do you not have to worry about the future, the journey you're about to embrace? Why is engineering, why is science so important in that overall sustainability aspirations? And why can you be pretty much certain to get a job, and why will you not be replaced by artificial intelligence and the likes? So these were the 3 why questions I answered for them.
Those are good questions. So just like a good kid, I want to dig into the first one because even as we advance in our career, I think there's something about today's modern society. I don't know if it's the phones or the social media, but it seems like we're safer than we've ever been. And yet we worry more than we ever have. So
Yeah.
what was your advice to these kids on why they don't have to worry?
Yeah. And it was on 2 levels, probably. One, or the first level was if you reflect on their journey over the last 5 years. So they are probably the type of graduates that had it the hardest. So they had to work their graduating years and their end of university years through COVID. So speaking of having a hard start and a tough journey to where they are at, they had that. So, and they came through it. So from my end, my point of view was, you managed to do that. What else can there be that you cannot do? And the second part was that with the tools they've been given, critically analyze challenges, find solutions, especially the solution part. People are very quick to give you the list of all the problems, but these graduates have been trained at finding solutions and validating solutions. I couldn't think of many skills going forward that doesn't matter what our economy will look like, that will definitely not be replaced or definitely will be important. So that was probably on that topic.
That's absolutely true. And it's funny when you told me you were calling in from New Zealand, I always think of folks from New Zealand as being very solution oriented and having a high level of ingenuity. So maybe talk a little about New Zealand. What's it like being there? And then in general, where do you think that ingenuity comes from?
So I'm not born in New Zealand. I was born in Germany. I've been living here now for about 10 years. So my wife is New Zealander and my kids are. So is probably a perspective of someone who moved to the country, didn't grow up here. On the ingenuity side, you can absolutely understand, New Zealand is at the end of very long supply chains, very much at the end of any shipping line. And we see it with our engineers, with our staff. People got used to through decades, through generations, through their growing up. You learn to deal with problems. You learn to deal with problems on your farm. You engineered a solution. You were able to fix it. Well, just go to the store and buy the other part that didn't work. So you learned how to fix, make, do anything. So we refer to that here as number 8 wire mentality. So it's a piece of wire, you can basically make everything of it. It has its great advantages, and as a general manager, it's fantastic. So our people come up with solutions where you wouldn't believe it. You are truly at awe at it. The problem becomes then when you want to industrialize and bring it into existing supply and manufacturing chains. So suddenly, how did you make that? Like what standard did you use? And so this is where you have to bring, and this is why international partnerships for New Zealand are so critical. We are such a great creative country, and then how can we partner with other parts of value and supply chains to really roll it out as an export nation? So that's probably that part. In terms of living in New Zealand, I think, especially in that transition to bioeconomies and circular economies, that's one of the biggest opportunity, it's probably a generational opportunity that this country now has. We are amazing in terms of growing biomaterials. So New Zealand pretty much invented plantation forestry. So there are not many countries that can grow sustainable biomass as well as we can. And what we've done so far is we're growing the biomass, we're harvesting it, and then we're putting that pretty much unrefined without any further value added onto boats to ship them off. And what you can think about now is, and that's what I spoke before, let's bring biorefining, biomanufacturing onshore, and instead of selling a log, let's sell bioplastics, let's sell advanced materials, let's sell high-value bioproducts. So there's that big opportunity that we are now from moving into this advanced bioeconomy. And the other thing that I'm always observing here is how international our country is, or our companies. I think we are about 350 people. We've got 28 nationalities. That's an incredible melting pot of ideas, concepts, and approaches. And the last part you definitely need to know about New Zealand is that strong, very strong Indigenous Te Maori culture. Again, a massive opportunity for the country to build this economic transition, not just on global or Western science, but also embedding Indigenous knowledge where circular systems, bioeconomy are actually a critical part of it. And that's one of the most exciting things now, to see how we are working between these two knowledge systems, and the magic actually happens when you bring these two knowledge systems together.
I couldn't agree more on that, because there's a lot of knowledge to be gained by Western ideas, but also there's so much knowledge that's been passed down generationally. And I think we as modern Westerners often look down on traditional knowledge, not recognizing how many generations and thousands of years it took to accumulate that. And that goes for indigenous knowledge, religious systems, philosophical systems, and all these different ideas that really underpin what we stand on now. Because most of the things that we're doing, we didn't invent this generation. So it's always important, I think, to look at with gratitude at our ancestors and what they were able to achieve with a lot less really than what we have. So
Yep.
it's pretty amazing.
And I think this is where the reason I can see further is because I'm standing on the shoulders of giants. In science and technology, that couldn't be more accurate, because anything you do now is built on the amazing knowledge and the amazing endeavors of who came before. So yeah, I think you always have to keep that in perspective, especially in science and technology.
Very true. So I'd be remiss if I didn't ask a little about finance, because I am an investment banker and it's what I focus on. A lot in the United States, we see some of the research institutes producing really great ideas that ultimately turn into venture capital backed startups.
Mhm.
Is there a startup ecosystem in New Zealand in the climate energy transition world? And do you see it growing? Do you see finance coming in from outside, from the US and other places, or is it more localized? What are you seeing in the financial sector, particularly in the startup world?
So the it's that's an interesting question because New Zealand never had that really strong venture capital ecosystem, not compared to the US or North America. So I came from a larger conference in Alberta, and the room was full of 2,000 scientists, 2,000 VCs, basically. Yeah, I was blown away. But especially in the area of clean tech, climate tech, biotech, very much along the line of what President Biden talked about, this opportunity in these areas, we can see big changes over the last year, probably 3 years, 4 years. And companies now, or venture capital is actually available for endeavors that we wouldn't have thought before. And maybe two examples I could talk about that we are closely involved with. One is a company in New Zealand called Cytogenics. And that's a company that looks at boosting anaerobic digestion. So you always get left with certain amount in anaerobic digestion, so producing biogas that can't be utilized. And this is a company that is investigating how to build modular units to bolt that onto biogas plants to really up the efficiency and get the biogas amount increased. And that's based on our campus. We're working closely with them, received funding. I don't think, 5 years ago that would have been possible. And so it's really exciting to see that also new jobs coming in. The other one, and this is a Maori owned company called Agri, and they worked with us, or they're working with us for several years, and they start using different types of seaweed. And they used it for cosmetics, they used it for fertilizer. And we met them at a conference and we started talking about, oh, what are you doing with all the things that you left behind when you process seaweed? And we introduced them to a concept or to a material called nanocellulose. And so you can process seaweed, you can do all the great and fantastic products they do. And now we start working with them, taking their waste or their leftover and process that to nanocellulose. And what's that good for? Well, at the earliest stage or at the least refined stage, you can use it around planting pots, and planting better, like increase the amount of how trees can grow. But you also can use it as material in digital devices, in wound healing, in electronics, and all the other things. And suddenly, so I have a rural regional company in New Zealand that came out of the, fertilizer type business, now is processing material that could end up in the cell phone that you're holding.
It's incredible the convergence, these kind of material science and bioscience as they're coming together. I'll throw out another company. We've been tracking a company called Fabrum that
Yeah.
has received financing from AP Ventures, which is a big UK based venture capital fund in the area of cryogenics, particularly around hydrogen, liquefaction and being able to liquefy hydrogen in order to transport it. We're definitely seeing in the United States biofuel, or let's say RNG type economy,
Mhm.
really accelerate a lot faster than hydrogen. But we do think that there's opportunities in hydrogen as a zero emissions fuel in the future as technologies emerge. And Fabrum seems to be a really good company in that area.
Yeah, I would agree with that. We had recently a climate change and circular economy discussion in Auckland, organized by the French New Zealand Chamber of Commerce, pretty much. And they brought in R&D professionals from Airbus, for example. And so we had the discussion around what's the next generation. So, and you can see today's planes can fly on liquid biofuels. That's true. And They also spoke about the hydrogen part. So this is not, let's not debate when it will happen, but you could see there's a lot of companies putting new technology in. The other interesting thing for New Zealand is the electrification of planes. So we will likely see electrification for domestic flights. So that works within New Zealand. The moment, shows how far away we are from the rest of the world. The moment we want to fly to Australia, which is 2,500 kilometers, at the moment, that's not likely to happen with battery systems. That's where you will need liquid fuel.
It's hard to imagine. You always think New Zealand's right next to Australia, but it is pretty far away. It's incredible. Totally
Or
agree. And I think your philosophy around using everything is in alignment with how I think New Zealanders think, which is this ingenuity component. But ultimately, that's what the energy transition, I think, will have to be. We won't have this silver bullet of fossil fuels. So we have to use all this other ingenuity in order to replace them in all different areas.
yeah, I totally agree. And this is where it's interesting. Waste is very much a human concept. So humans pretty much invented waste. If you go into nature, that concept of waste does not exist. Whatever is left in one process is the starting material or starting feedstock for another. And that's the way we want to think about anything. So when we look at a tree, in the past, you might have, I can only use the middle part of the tree. The rest is, too thin, too green, too, whatever. And we want to look at it. No, you need to use everything that there is because it's too valuable. We can't afford that. A lot of effort has been put in, a lot of energy has been put in to grow that. And that's the philosophy we have. And again, coming back to an indigenous or Te Maori mindset that is similar there, where these are resources. This is not waste, is very much embedded.
That's right. Use it all. And it goes back to the movie in the 90s, Dances with Wolves. I still remember it as a high school student watching this movie and how they used every aspect of the buffalo versus throwing away certain parts of it. How the indigenous North American people were so resourceful. And I think we absolutely all can learn from that.
And I think this is where we are coming from, that to that point. Yes, we will come up with new, amazing, innovative material, but that alone will not solve it. Like it's not the silver bullet, as you said. There might be a relearning of, things we might have lost on the way, in how to use a whole buffalo, or how to use every part of, in the food chain, for example. Much more knowledge, different processes, and different, look at things completely differently.
Florian, this has been a great conversation. Tell the audience how they can get a hold of you.
Thanks for having me. So the easiest is look me up on LinkedIn, connect, and you can follow a number of our developments. We are putting out quarterly and bi-monthly newsletters. So yeah, you can stay on top of what Scion is doing in that circular economy, bioeconomy space.
Very good. Florian, thank you for being on. This has been Florian Graichen with Scion. He's the general manager in charge of forestry and bio-based products. Thanks for being on today.
Thanks for having me, Peter.